A very good morning to all of you students. I am Dr. Halima Sadia, Assistant Professor, Department of Computer Science and Engineering, Integral University, Lucknow. I am going to teach the module Block Diagram and Protocols of IoT in the value added course on CSV 05 Internet of Things. These are the topics that will be covered in this particular module. First, we will take a look what IoT is, working of an IoT system, the basic building blocks of IoT, physical and logical design of IoT system, the generic block diagram of IoT devices, and finally the IoT protocols. Now, before moving into the details of the other topics, we should first know what IoT is. As discussed already, we all know that IoT or Internet of Things refers to the things that are connected to the internet or a network. IoT is shaping the way we live our lives. IoT is a system of interrelated devices connected over the internet or a network, used to transfer and receive the data from one node to the other. A very good example of IoT is a smart home. We can think of a number of devices that are connected in a smart home. We have AC, we have doorbell, we have thermostats, we have smoke detectors, water heaters, security, alarms, etc. All these devices are interconnected to share the data with the user on the mobile phone. Until now, the internet enabled the people to connect and communicate with each other. However, with the advent of Internet of Things, now we are able to connect the objects, that is the things, and these things are now having the ability to sense the surroundings, communicate with each other and collaborate with one another. So, the Internet of Things is nothing but a network of things that uses or embedded with software, sensors, connectivity and electronic devices to collect and exchange the data from the outer world. This is used to improve the efficiency, accuracy and benefits of the ecosystem. To collect and exchange the data from the outer world and improves the efficiency, accuracy and benefits of the ecosystem. As we can see over here, IoT is with respect to any context, any time. It can be anybody, anyone connected over the network. It can be any business, any service. It can be any network on any path. It can be any device or anything, or it can be anywhere and any place. So, IoT provides all this. The IoT ecosystem can be thought of as a collection of web-enabled smart devices that use embedded software systems, processors, sensors, actuators and communication hardware. Now, all this is used to collect, sense the data. After collecting, this data is sent to the cloud and the processing is done, based on which action plan is done. We can see over here that the IoT is connected and is present in almost every walk of life. It is being used in vehicles, home and appliances, musics, personal computers, data analytics, flight services, online shopping, wearable technologies, smartphones, home lighting devices, etc. Now, if we all concentrate on this picture, what is shown over here is that the IoT devices are basically categorized into two types, the general devices and the sensing devices. The general devices can be thought of as data hubs and information exchange. These can be connected through wired or wireless networks. These are all the appliances that we can think of. It can be an AC, it can be a TV, alarm system, room heaters or lighting systems, anything, any such devices. Then we have the sensing devices. These sensing devices are nothing but the sensors and the actuators which are used to measure the temperature, the humidity, the light intensity. Now, what happens is that we have gateways. These gateways are basically IoT devices that are connected to the network via these gateways. These gateways or processing units process the data collected from the sensors and transfer it to the cloud. The cloud acts as both the storage and the processing unit, and then based upon the data analytics, an inference can be made out of it. So, this is how an IoT system works. The devices are there, general as well as the sensing devices, we have gateways, we have a cloud storage, and then we have several data processing units that basically convert the captured information into meaningful one. Next, we are going to discuss the basic building blocks of the IoT system. The basic building blocks of the IoT system are sensors, processors, gateways and application. Each of the block of this IoT system constitutes of its own characteristics to form a dynamic IoT system. To start with, we have sensors. Sensors are the front end in an IoT system. The main aim of the sensor is to collect data from the environment and give out this data to the environment through actuators from its surrounding. Sensors are identified with the help of a unique IP address. Therefore, they can be easily differentiated over a large network. They can either work on their own, or they can be initiated, or they can be activated by the users depending on the need. The examples of sensors are gas sensors, water quality sensors, moisture sensors, etc. Then we have processors. Now, processors, as we all know, are the brain of the IoT system. The main function of the processor is to process the data captured by these sensors and process them so as to extract valuable data from the enormous amount of the raw data that has been collected by the sensors. The processors mostly work on a real-time basis and can be easily controlled by applications. These are responsible for securing the data, that is performing encryption and decryption operations on the data. Embedded hardware devices, microcontrollers, etc. are a good example of processors, devices that have processors attached to them. The next are the gateways. The gateways are basically used to route the processed data and send it to the location for proper utilization. Examples of gateways are LAN, WAN, PAN. The next are applications. Applications are important for the proper utilization of all the data that has been collected. These cloud-based applications are responsible for rendering effective meaning to the data that has been collected by the sensors and being processed by the processors. Applications are controlled by the users and are a delivery point of all the services that are to be provided to the users of the IoT system. Example of applications are home automation apps, security systems, industrial control hubs, etc. Moving on further, let's take a look over the physical and logical design of the IoT system. The physical design is about forming an overall intelligent system. The design must be oriented towards the end user needs. However, the logical design of an IoT is an abstract representation of the processes and the entities. It does not deal with the complexities of the implementation details. Physical design, however, involves the complexities of the implementation. The physical design of an IoT system mainly comprises of two components: the things, also known as devices, and the IoT protocols that are used to build an IoT system. All these things or devices are called as node devices, and every device has a unique identity that performs remote sensing, actuating and monitoring work. However, the protocols that are used to establish the communication between these node devices and serves over the internet. The things can be anything that operate or functions by electrical and electronic means. It includes electrical machinery, electronic gadgets, sensors, actuators, transducers, controllers, processors, etc. These devices have unique identities, that is, they are identified with the help of IP addresses or URIs. Sensing, processing, actuation and monitoring operations are performed. These exchange the data with each other, send the data to a centralized server or cloud-based applications for back-end processing, perform some tasks locally and the other tasks remotely based upon the need. These things and devices are used to build a connection, process data, provide interfaces, provide storage, provide graphics interfaces in an IoT system. All these in turn generate data in a form that can be analyzed by an analytical system and programmed to perform operations that are used to improve the IoT system. The logical design of an IoT system can be termed as an abstract representation of the entities and the processes without going into the low level specifics of the implementation. The logical design constitutes of IoT functional blocks, IoT communication models and IoT communication APIs. The things and the devices along with the protocols are basically the main component of the physical design of the IoT system. These node devices are basically the design units of an IoT system, and they are used to build connections for data processing, to provide storage, to provide interfaces and to provide graphical user interfaces to the system. The protocols in turn are used to establish the communication between the node devices and the server devices, and also there are a number of protocols and interfaces that are required to be seen when we are establishing an IoT system connections. Generic block diagram of IoT devices. The picture shows the generic block diagram of IoT device. It may constitute of several interfaces for connection to other devices. IoT devices have input-output interfaces for sensors, similarly for internet connectivity, for storage and for audio-video purpose. The IoT device basically collect the data from on-board or attached sensors and sends the data communicated either to other device or to the cloud-based server. Now, these cloud-based servers are available for the IoT systems. These are high-end servers. They collect all the information from the sensors, and then these cloud-based servers are responsible for providing or using data analytics to convert this information into meaningful results. Now, let us one by one go through the components of the generic block diagram of IoT devices. As we can see in this picture, we have connectivity, we have processor, we have audio video interfaces, we have memory, we have graphics, we have storage interfaces, and we have input output interface for sensors and actuators, etc. Each component then comprises of other units that are attached to it to provide the overall functionality to the IoT systems. We will one by one discuss the components in detail. The USB host and the Ethernet under the connectivity module are used for providing connectivity between the devices and the servers. that is the IoT devices that are connected and the cloud server that is connected. It provides an interface or connectivity between the devices and the server. The processor unit, as we all know, it is a CPU. It can comprise of a CPU and other units which are used to process the data. This data is further used to improve the decision quality of an IoT system. The graphics unit, the graphics processing unit GPU, is a specialized processor originally designed to accelerate the graphics rendering rendering system. Now, the memory unit is also there to provide storage. Then we have the audio video interfaces. It comprises of HDMI, which is high definition multimedia interface, a standard for simultaneously transmitting digital video and audio from a source. We have 3.5 mm audio headphone jack. It is an industry standard audio plug, most commonly used for connecting a pair of stereo headphones to your smartphone. Then we have RCA video. These RCA cables are specifically used to connect the audio and video components of a variety of devices. We can include television, gaming consoles, DVD players, VCRs, speakers and cable boxes. Then we come to this storage interface unit. It constitutes of SD. SD is a standard, it offers great flexibility, includes the ability to use the SD slot for more than memory card. Then we also have a MMC card, which is multimedia card. It is a flash memory card standard. Typically an MMC is used as a storage media for a portable device in a form that can easily be removed for access via PC. Secure digital, SD is basically secure digital, is a flash non-volatile memory card format and is used for storage. Then we have SDIO. SDIO stands for input output functionality, and SD is only for storage memory. So the SDIO card size is basically used over here or is able to interrupt the host processor, while SD does not interrupt the host side. Host has to read or write to the SD card. Then moving on to the input output interface for sensors, actuators, etc. If we see over here, we have 4 units. We have UART, we have SPI, we have I2C and we have CAN. One by one we will elaborate, I will be elaborating on each functionality, each unit's functionalities. UART is basically a universal asynchronous receiver transmitter. It is one of the simplest and the oldest form of the device to device digital communication. It is a protocol like SPI and the I2C, but it is a physical circuit in a microcontroller or a standalone IC. It can be thought of as a computer hardware device for providing asynchronous serial communication in which the data formats and transmission speeds are configurable. It is a very important note that the data formats and the transmission speeds are configurable. Then UART's main purpose, as we all know from the name itself, universal asynchronous receiver transmitter, the main purpose is to transmit and receive serial data. One of the best things about UART is that it only uses 2 wires to transmit the data between the devices. There is 1 wire for transmission and 1 wire is there for receiving the respective data. The transmitting UART converts parallel data from a controlling device like a CPU into serial form. It transmits it over the communication medium serially to the receiving UART, which then converts the serial data back into parallel data for the receiving device. Next we have SPI in the generic block diagram. SPI stands for Serial Peripheral Interface. It is an interface bus which is commonly used to send the data between microcontrollers and small peripherals. If we all remember what a bus is basically used to transmit the to and fro data. It carries the data to and fro. It basically acts as a bus and is used to send the data between the microcontroller and the small peripherals. The small peripherals can be shift registers or sensors or SD cards. It also separates the clock and the data lines along with the select line to choose between the device that a particular user wishes to talk to. It is a master and a slave type protocol that provides a simple and low cost interface between a microcontroller and its peripherals. So, the connectivity will be a master slave kind of a connection. Then the next in the generic block is I2C, which is general purpose input output GPIOs, inter-integrated circuit. I2C combines the best features of SPI and UART. That is, with I2C we all can connect multiple slaves to a single master. That is, in SPI we have a single slave and a single master. However, in I2C we can connect multiple slaves to a single master device, and we can also have multiple masters controlling multiple slaves, single or multiple slaves. It is really useful because when we want to have more than one microcontroller, then we logging data to a single memory card or displaying text to a single LCD, we can use multiple interfaces for the same unit. Then the last in the generic block is CAN. If we see over here, CAN is Controller Area Network Bus. It is basically a high speed hardware independent and very flexible connected card used for expansion. It allows the microcontroller and the devices to communicate without a host computer. We do not need a host computer for communication. It is two wired, half duplexed, high speed serial network technology. So, this completes the generic block diagram of the IoT devices. If we can have a quick review, then I would like to summarize that the generic block diagram constitutes of connectivity. In connectivity we have USB and Ethernet. For processor we have a CPU. Then for audio video interfaces we have HDMI and RCA devices. For input output interface we have UART, SPI, CAN, I2C. For storage interfaces we have SD, MMC and SDIO, used to store the data generated from an IoT device. And for memory and graphics we have DDR and GPU, which is the graphical processing unit, to provide the graphics related functionality to the IoT system.